So today we're talking about distributive property. The algebra unit in grade 9 is pretty short. Okay, we'll be done by the end of this week. We have a test on Friday. I think I already told you that. It's really just, we've already talked a bit about collecting like terms. We're doing distributive property today. We're talking about multiplying stuff tomorrow. Then we do distributive property again, and that's it for now. There's a few other parts to it. We'll do some of it maybe when we get back. There'll be algebra throughout the rest of the course from time to time for sure. But the algebra unit is pretty short. And we really only learn a couple of little things about algebra in grade 9. And then we use those things throughout. But it gets way bigger in grade 10 and grade 11 and grade 12. But distributive property is a hugely important skill that you will use every year, and you'll use it in other places too, like you use it a lot in science and possibly even in a few other courses. So it's pretty big skill. It's really one of the one that we learn in grade 9. Algebra is a funny thing because people think math is about getting the answer. I talked about this a little bit the other day, I think. It's about getting the answer. And your answer should be like a number, like 5. And it's not always. And there's this strange thing about algebra in high school where we're just learning skills and it's not about getting to an answer. As you can see, what I've written here, it's about manipulating an expression. And the thing that you'll have to, and it's a little bit tricky in grade 9 because we don't do much algebra, but you'll find eventually, start seeing it in grade 10, sometimes you want your expression, your equation, or your formula, or whatever you're looking at, to look like this, and sometimes you want it to look like that. And there's just different ways that we want these things to look. And that's what algebraic skills that manipulate expressions are all about. So for us in grade 9, we're just doing distributive property, so it's always kind of going to look the same. But that's not always the case in math. So keep that in mind down the road when you go to grade 10, grade 11. Like, there's sometimes you go this way, sometimes you go that way. That's part of it. Part of it is you figuring out what form you want the equation to look like. In fact, we'll see a little bit of it in grade 9 now that I think about it when we start looking at equations of lines. Okay, so and it's kind of like we learn to multiply, which is going one direction, then we learn to divide, which is going the other. Okay, and algebra can be like that as well. We learn to go both directions with it. But in grade 9, we're really just doing distributive property. Distribute, if you think about what that means, is funny. It's one of those words where everybody kind of knows what it means, but it might be a hard one to actually define or explain in your own words. Pamphlets or pages, if I hand out a worksheet or something, I'm distributing them to the class. What do? I have a bunch of them, and I give one to everybody. And you can think of distributive property as the same in mathematics, where what this expression means is I've got a 2, and I'm giving it to everything inside the bracket. Okay, but I stop at the end of the bracket. I don't keep giving them beyond that. I just have 2 of that bracket. That's what that means. So what we end up doing, and we don't usually write it out this way, but I take this 2 and I multiply it by the x plus that same 2 times the 4. So 2 times x and 2 times 4. And you can write these little guidelines. I would strongly recommend doing that until you get good at this and you're never making mistakes. Okay. Notice how this means multiplication, 2 times this. So I multiply 2 times the x and 2 times the 4. This might be new. You might not have really seen this before. This is kind of like a BEDMAS question. I've got brackets. And so BEDMAS says I should do the brackets first. The problem is I can't add x and 4. They're not like terms. There's nothing I can do to them. It's not 4x. I can't mash them together. I can't do anything with them. So that's where these algebra skills like distributive property come into play. It allows me to manipulate the expression, change what it looks like when I can't actually do the adding. So what is 2 times x? It's just 2x. What is 2 times 4? It's 8. And now I have what we call this expanding. Sometimes we might say simplifying, although that's a little bit of an unclear term in some cases. But I've gotten rid of the brackets using distributive property, and that might be useful. Why? It's hard to say without actually seeing it in action, which we're not going to see right anytime soon. We will down the road. But it's one of those things where maybe you're going to do this, maybe you're not. Don't worry about that for now. For now, we're just practicing it, so we're always going to do it, right? It's going to say expand using distributive property, or expand or simplify, and you're going to use distributive property to do that. Okay? I think this is going to be pretty easy. I think you're going to be pretty good at this. There's a couple of cases that are a little bit trickier. It's going to get harder after tomorrow when we add a new layer to it. That's when people start making mistakes. For some of you, you're going to be good at this and not really even think about what you're doing. But you can always remind yourself that we're following mathematical properties. So let's do a check and see if this actually works. We are going to do this question twice. Do you agree this is a BEDMAS question? That's what it looks like. So how would you solve it with BEDMAS? Instead of x plus 4, it's like I've got 5 plus 4, right? I would do brackets first. So do you agree 5 plus 4 is 9? Yeah. And 2 times 9? 18. What if I used BEDMAS, or what if I used, distributive property on this? Now this is weird. I don't know why you ever would. Because you would use BEDMAS probably. But the whole point is you could. It's not something that's only true for variables. The whole point is it's true in mathematics. So I could do 2 times 5 plus 2 times 4. And then still using BEDMAS, multiply first. 2 times 5. 2 times 4 is 8. 10 plus 8, oh, look at that, 18. Coincidence? No. This is the whole point is, and this is not a proof, but I think it's satisfying to show us that distributive property doesn't change the expression. It doesn't change the thing that you're looking at. In other words, the 2 times x plus 4 is the same as 2x plus 8. They are the same for all values of x. No matter what x you put in there, you'll get the same on both sides. That's what that means. Okay? We haven't changed the expression. This is an important idea in mathematics. Any questions? But like I said, it's pretty simple. If you want to try this one, go for it. So what's different about this one is it's a trinomial. I'm going to multiply the and what do we get? So there's something. Does anybody have it? Who wants to give this answer? Somebody want to give it a try? Ben?
Negative 3x squared plus negative 9x minus 3.
Nice. And I'm going to change. You could write it as plus, and you would probably use brackets like that, plus negative 9x. That's correct. But you could also simplify this, and usually we would try to, if we can, to just negative. So minus 9x, and I missed what you said, but I think it was plus 3. Negative 3 times positive 1, or times negative 1 is positive 3. So there's a little note that we might want to make over here, and that is, how did we get the negative 9? Because we haven't done this yet. When I do negative 3 times 3x, that's negative 9x. So you multiply the coefficients. Remember that word. That's how you multiply when you've already got a number in front of an x, like when you've got a variable term with a coefficient. We know 3x squared is 3 times x squared. So when I go 3 times x squared, I get 3x squared. Like, that's what that means. But what about negative 3 times 3x gives you negative 9x? That's probably something that you've seen. Okay, let's try this one. What's going on with this one? What is that in front of the brackets? It's a negative or a minus sign. Some people might think of it. It means the same thing. What else could you think of it as? Very good. It's like a -1. So I'm gonna put that in there. We wouldn't usually write it, but just as a note to ourselves or a reminder that it's like a -1. So it's -1 times 3 and -1 times x is how you're going to do this. This is an important one because this happens a lot and it's a mistake a lot of people make. People would do this. What's my mistake? Some people might be like, I don't see a mistake. I think you did it correctly. What's my mistake? Ben?
Well, then x is negative.
Yeah, it's -1 times 3 is -3. -1 times negative x, shouldn't that be positive x? Negative and a negative make a positive. So don't forget to multiply it by everything inside the bracket. You don't just stop at the first thing. Again, some people might do this. Why is that wrong? Forgot to multiply by the 4. It should be 2x plus 8. I did 2x plus 4. Okay, that's common mistake. Do I have any more there? No. Okay, so that's very simply how you use the distributive property. Now, the other kind of question that we see is this, where you have to expand and then simplify. So when we say expand, we usually mean multiply through using distributive property. Simplify means collect like terms. Because I have 2 brackets, I might have like terms in the next step. You might or you might not. Usually we will, because that's the point of these questions. And I just want eyes up for a second here. I know you're writing this down, but I just want you to look. This says I have 2 of this bracket. Literally, I have 2 of them. 2 of that bracket. 2 of everything inside that bracket. 2 of this, 2 of this, and 2 of this. But I stop at the end of the bracket, and I've got 3 of that bracket. So again, sometimes, this is kind of a big mistake, people multiply and keep multiplying. Just keep multiplying by everything they can see. But that's not how you do it. Okay, so you got to know when to stop. So it's going to be 2 times that, and that, and that, and then 3, or -3 times that, and that, and that. So let's give it a try. 2 times 3a. 2 times 3 is 6, so 6a. 2 times -4, -8. And brackets are gone. We don't usually use brackets in the next step. Some people like to because they kind of just helps them organize their thinking. It's probably okay if you do that, but you don't need them. 2 times -4 is -8. I think it should be negative. -3 times a squared. So watch, I'm just going to combine them by going -3a squared. -3 times -a, 2 negatives makes a positive. Same rule applies as always. And 3 times a is 3a. -3 times +5 is -15. Again, take a look. I had 3 terms. I had a trinomial inside the brackets, and I still have those 3 terms. I had a trinomial here, and I still have those 3 terms. When you use distributive property, you don't change the number of terms. I had 3 up here, 3 down here. 3 up there, not including the -3 out front. Inside the bracket, there's 3 terms. Still 3 terms. There has to be. So that's a check. Now in the next step, you're going to change the number of terms, possibly, because when you collect like terms, you're going to reduce. And I'm going to add that step where I rearrange putting the a squareds together, putting the a's together, so 6a and 3a, and putting the numbers together, and see how it starts to get more complicated. Remember, the signs have to go with the terms that they belong to, so -8 is still -8, -3a squared is still -3a squared. 2 minus 3 is -1. 6 plus 3 is 9. -8 minus 15 is -23. Any questions? That's it.